Welcome back, fellow humans. This is part 2 in our series on all the logic needed for logic games. In the previous video, we talked about the contrapositive as the only valid inference that you need to draw from a conditional, and we looked at how to form the contrapositive quickly and efficiently. In this video, I want to look quickly at some tips and tricks that you can use on the LSAT based on what we saw in the first video. Now, these tips and tricks really apply only to logic games, but of course they're logically accurate and can be used anywhere. And just as in the first lesson, we're going to do a quick guide and then we're going to take a look at the reasoning behind what's going on. But before we get there, I want to talk a little bit about terminology to make it easier for me to talk about what's going on. So suppose that I have a conditional of if P then Q. Each of these terms of the conditional, the P and the Q, have labels. They have names. And what follows immediately after the if, so P in this case, is called the antecedent. Why? Because logicians are not the most creative people when it comes to naming things. An antecedent literally means what comes before. And the variable P here, since it is the condition, literally comes before the outcome Q. So we call that the antecedent. And the second variable, what would follow the then in an if-then statement, so Q here, is called the consequent. And once again, consequent literally means what follows immediately after. So when I speak about the antecedent, I'm talking about this initial condition. And when I speak about the consequent, I'm talking about the outcome, what comes after that condition. So now you know what I'll be referring to if I talk about the antecedent or I talk about the consequent. Got it? Let's get started. If you see a conditional that looks like this, where the consequent is negated, but the antecedent is not negated, then immediately convert it to this. And this is my graphical way of representing that P and Q can never occur together. So what this symbolization on the bottom means is that P and Q will never be together. You can have P but not Q, you can have Q but not P. Now let's look at the second quick tip. If you see a conditional like this, where the antecedent is negated but the consequent is not, then this means the same thing as either P or Q in an inclusive sense, which we'll talk about a little bit later. So that's the quick guide. That's something to remember. If the antecedent is positive but the consequent is negative, then it means that the antecedent and consequent can never be together. If the antecedent is negated but the consequent is not, then that means exactly the same thing as either the antecedent or the consequent is true in an inclusive sense. And now we're going to take a look at the reasoning why. Now, instead of using variables, what I want to use is accepted or unaccepted. So I want it to be similar to an LSAT type rule where something is in this case accepted, or something is out, in this case unaccepted. So when I say P in a positive way, when I have not Q, what I mean is accepted and unaccepted, and you'll see what I have in mind. So in this expression, if P then not Q, let's rephrase that according to this accepted-unaccepted distinction. What we would be saying is, if P is accepted, then Q is not accepted. So we're distinguishing what can be in on the one hand and what can be out on the other hand. If P is accepted, let's say to law school, then Q is not accepted to law school. Now we go ahead and take the contrapositive. And remember, to take the contrapositive, we first reverse the terms, negate each term, and form a conditional between those two new variables. Now, as you can see, P, since it begins positive, when we negate it, it's not P. But Q, since it begins negative, goes to positive, not Q goes to Q. Remember, in the last video, we said that negation in logic changes the truth value, and it's like a light switch that goes from on to off, from positive to negative. So in this case, if the variable is positive, its negation is negative. If the variable is negative, its negation is positive. And now you're prepared to see what I want to show you with regards to why that initial quick guide strategy works, where if you see a conditional like this and the antecedent is positive, the consequent is negative, that means the same thing as saying that P and Q can never be together. P and Q in this case could not both be accepted to law school. And we can see that if we look carefully at this stacked conditional with its contrapositive. Remember, everything on the left side can't be true together, and everything on the right side can be true together. So it would never be the case that P and Q are accepted together, but it could be the case that both Q and P are not accepted. So what this says is that if P is accepted, Q is not. If Q is accepted, P is not. So anytime that we have P, we can't have Q. Anytime we have Q, we can't have P. But we could have neither. Both Q and P could be out, but they can never both be in. And that's what we represent in that graphical presentation I gave you before that looks like this. So instead of diagramming the contrapositive when you see a conditional like this, you can go immediately to recognizing that P and Q can never be together, but P and Q could both be out at the same time, both be unaccepted, but in this case they can't both be accepted, and you can represent that the way that I have here. All right, now let's take a look at the other one. The other one starts with the antecedent negated and the consequent not negated, and that looks like this. If P is not accepted, then Q is accepted. And we take the contrapositive the same way. We reverse the two variables. We negate both variables. In this case, not P is negated and becomes P. Q is negated and becomes not Q. We form the conditional and we're good. And as before, we know that everything on the left side cannot be true. So in this case, P and Q cannot both be out. It can't possibly be true that P is unaccepted and Q is unaccepted. They can't both be out. If one is out, then the other is in. However, everything on the right can be true. And this is what I mean by inclusive disjunction. Either P has to be in, or Q has to be in, or they can both be in together. Now, this may seem unusual to you, but logically, the fact that both can be true is guaranteed by the logical meaning of a disjunction. Now, most of us are familiar with disjunctions as though they were exclusive, one or the other, but not both. However, logically, a disjunction is by default considered to be inclusive. And that's what this means here. Either P is accepted or Q is accepted, or logically both can be accepted. It is important to remember that the LSAT uses primarily the inclusive sense of disjunction. If they intend the exclusive sense of disjunction, they do specify that, usually in the rules or conditions. They'll say either P or Q, but not both. And in that way, they specify that the disjunction is intended to be exclusive. Otherwise, on the LSAT, you should always consider the disjunction to be inclusive, in which case both disjuncts can be present together. All right, hope you enjoyed that and keep watching.